The best method for splicing damaged 500 MCM Hypalon insulation on submersible pump power cables involves careful preparation and the use of appropriate materials. The materials required include firstly, heat shrink tube with a diameter larger than the outer diameter of the cable, secondly, a heat gun, thirdly, electrical tape, and fourthly, a solvent for cleaning. The procedure begins with preparing the cable. Firstly, cut away the damaged insulation, leaving enough cable length for splicing. Secondly, clean the cable ends with the solvent to remove any dirt or debris. After preparing the cable, the next step is to install the heat shrink tube. Firstly, slide a heat shrink tube over each cable end. The tube should extend beyond the bare wire on both sides. Next, twist and solder the wires. Firstly, twist the wires of the two cable ends together. Secondly, solder the twisted wires to create a secure connection. Following the soldering process, install the insulation. Firstly, slide the heat shrink tube over the soldered connection. Secondly, use a heat gun to shrink the tube. This will provide insulation and protect the connection from moisture. The next step is to wrap the splice with electrical tape. Firstly, wrap electrical tape over the ends of the heat shrink tube to further secure the connection. This will also help prevent moisture from entering. Finally, inspect and test the splice. Firstly, visually inspect the splice to ensure it is properly insulated and secure. Secondly, conduct an insulation resistance test to verify the integrity of the connection. Some important notes to keep in mind are: firstly, use high-quality heat shrink tube designed for submersible applications. Secondly, ensure the proper diameter heat shrink tube is used to provide adequate insulation. Thirdly, use a heat gun with sufficient heat to shrink the tube properly without overheating the cable. And fourthly, allow the splice to cool completely before submerging the cable. Additional considerations include: firstly, if possible, avoid splicing in areas where the cable is subject to high stress or movement. Secondly, regularly inspect the splice for any signs of damage or deterioration. And thirdly, consider using a protective enclosure or conduit to safeguard the splice from environmental factors. The heat shrink tube must be rated for submersible use, which means it must be designed to withstand continuous immersion in water at the operating depth of the pump. This typically involves specific material compositions and manufacturing processes to ensure waterproof sealing and resistance to degradation from prolonged exposure to water. The solvent used for cleaning the cable ends should be compatible with Hypalon insulation. Isopropyl alcohol is a common choice, but it's crucial to verify that it does not degrade or damage the insulation material. Always refer to the cable manufacturer's recommendations for suitable cleaning agents. When twisting the wires, ensure a tight and secure mechanical connection before soldering. This helps to maximize conductivity and minimize resistance at the splice. Use a soldering iron or gun with sufficient wattage to ensure proper solder flow and penetration into the twisted wires. The type of solder used should be appropriate for electrical connections and compatible with the conductor material, which is typically copper. Rosin-coarse solder is commonly used for electrical work. When applying heat shrink tubing, start shrinking from one end of the tube and gradually work towards the other end. This helps to prevent air from being trapped underneath the tubing, which can compromise the insulation and waterproofing. Overlapping each layer of electrical tape by at least 50% ensures a tight and waterproof seal. Use high-quality electrical tape that is designed for outdoor or submersible use, as these tapes typically have better adhesive and weather resistance properties. The insulation resistance test, also known as a Megger test, is crucial for verifying the integrity of the splice. This test applies a high voltage, typically 500 volts or 1000 volts DC, to the splice and measures the resistance between the conductor and the ground. A low resistance reading indicates a potential insulation fault. The acceptable insulation resistance value will depend on the voltage rating of the cable, but generally, a reading of several megohms or higher is desirable. If the insulation resistance reading is low, the splice may need to be reworked. When selecting heat shrink tubing, consider the shrink ratio, which is the ratio of the original diameter of the tubing to its fully recovered diameter. A high shrink ratio allows the tubing to fit over a wider range of cable sizes. Also, consider the wall thickness of the heat shrink tubing. A thicker wall provides better mechanical protection and insulation. When using a heat gun, maintain a safe distance between the heat gun nozzle and the cable to avoid overheating or damaging the insulation. Use a heat gun with adjustable temperature settings and start with a low temperature, gradually increasing it as needed. Regularly inspect the heat gun's nozzle for any signs of damage or blockage, as these can affect its performance. Avoid splicing cables in areas that are prone to mechanical stress or abrasion. If this is unavoidable, consider using a protective sleeve or conduit to shield the splice from external forces. The type of protective sleeve or conduit should be compatible with the submersible environment and resistant to corrosion and degradation from prolonged exposure to water. Regular inspections of the splice are crucial for identifying any signs of damage or deterioration, such as cracks, swelling, or discoloration of the insulation. These inspections should be performed at regular intervals, depending on the severity of the operating environment. If any damage is detected, the splice should be repaired or replaced immediately to prevent potential electrical hazards. When installing the splice cable, avoid sharp bends or kinks, as these can stress the insulation and compromise its integrity. Use cable support clamps or ties to secure the cable in place and prevent it from moving or rubbing against other objects. The cable support clamps or ties should be made of corrosion-resistant materials and compatible with the submersible environment. It's crucial to maintain detailed records of all splices, including the location, date of installation, materials used, and any inspection findings. This information can be invaluable for future maintenance and troubleshooting efforts. When working with electrical cables, always follow proper safety procedures, including wearing appropriate personal protective equipment such as gloves and safety glasses. De-energize the circuit before working on any cables or connections and verify that the circuit is de-energized using a voltage tester. Be aware of the potential hazards associated with working in a wet or submerged environment, such as electrical shock. Ensure that all equipment is properly grounded and that ground fault circuit interrupters, or GFCIs, are used to protect personnel. Consider the impact of the splice on the overall cable length and voltage drop. A splice can add resistance to the circuit, which can increase voltage drop, particularly over long cable runs. Use a cable voltage drop calculator to determine the impact of the splice on the overall voltage drop and ensure that the voltage at the motor terminals remains within acceptable limits. Document all procedures and materials used in the splicing process. This documentation should include photographs or videos of the splice at each stage of the process. This documentation can be invaluable for future maintenance and troubleshooting efforts. Consider the use of a waterproof sealant or encapsulant to further protect the splice from moisture. This sealant or encapsulant should be compatible with the cable insulation and the submersible environment. Apply the sealant or encapsulant according to the manufacturer's instructions. Train personnel on proper splicing techniques and safety procedures. This training should include hands-on practice and demonstrations. Personnel should be knowledgeable about the potential hazards associated with splicing cables and the proper use of tools and equipment. Regularly review and update splicing procedures and training materials to reflect industry best practices and any changes in technology or regulations. Use cable identification tags to clearly identify the spliced cable. These tags should be durable and weather resistant and should include information such as the cable number, voltage rating, and date of installation. Install the cable identification tags in a location that is easily accessible for inspection and maintenance. When selecting electrical tape, choose a tape that is specifically designed for use with Hypalon insulation. Some electrical tapes can react with Hypalon and cause it to degrade over time. Refer to the tape manufacturer's recommendations for compatibility. Consider the use of a splice kit that is specifically designed for submersible pump power cables. These kits typically include all of the necessary materials and instructions for making a reliable and waterproof splice. Follow the manufacturer's instructions carefully when using a splice kit. When soldering the wires, use a flux that is compatible with the solder and the conductor material. Flux helps to remove oxidation from the metal surfaces and promotes a strong and reliable solder joint. Apply the flux sparingly and clean any excess flux after soldering. After completing the splice, perform a pull test to verify the mechanical strength of the connection. This test involves applying a tensile force to the splice and measuring the amount of force required to break the connection. The pull test should be performed according to industry standards. If the splice fails the pull test, it should be reworked. Consider the use of a cable lubricant to ease the installation of the cable into the heat shrink tubing. This lubricant should be compatible with the cable insulation and the heat shrink tubing. Apply the lubricant sparingly and avoid getting it on the soldered connection. When using a heat gun, avoid concentrating the heat on one spot for too long. This can cause the insulation to overheat and degrade. Move the heat gun back and forth over the surface of the heat shrink tubing to ensure even heating. If the heat shrink tubing becomes discolored or charred, it has been overheated and should be replaced. Consider the use of a cable tray or ladder to support the cable run. This can help to prevent the cable from sagging or rubbing against other objects. The cable tray or ladder should be made of corrosion-resistant materials and compatible with the submersible environment. Ensure that the cable is properly secured to the cable tray or ladder using cable ties or clamps. When selecting a solvent for cleaning the cable ends, choose a solvent that is non-flammable and non-toxic. This will help to minimize the risk of fire or health hazards. Work in a well-ventilated area when using solvents. Dispose of used solvents properly according to local regulations. When cutting the damaged insulation, use a sharp knife or cable cutter. Be careful not to damage the underlying conductors. Make a clean and precise cut to ensure a smooth and even surface for splicing. If the conductors are damaged, they should be repaired or replaced before splicing. Consider the use of a cable gland to provide a watertight seal where the cable enters the pump motor or junction box. The cable gland should be sized appropriately for the cable diameter and should be made of corrosion-resistant materials. Install the cable gland according to the manufacturer's instructions. If the submersible pump is equipped with a cable monitoring system, ensure that the splice does not interfere with the operation of the system. The cable monitoring system may require special considerations when splicing cables. Refer to the pump manufacturer's instructions for guidance. When selecting electrical tape, choose a tape that is resistant to ultraviolet light. This will help to prevent the tape from degrading over time when exposed to sunlight. Store electrical tape in a cool and dry place to prevent it from drying out or becoming brittle. Consider the use of a cable marker to identify the location of the splice. This can be helpful for future maintenance and troubleshooting efforts. The cable marker should be durable and weather resistant and should be installed in a location that is easily visible. When working with submersible pumps, always follow the manufacturer's instructions and recommendations. The manufacturer's instructions may provide specific guidance on splicing cables or other maintenance procedures. Contact the manufacturer if you have any questions or concerns.